In this video, we will see how to convert epsilon NFA into NFA. So there are two rules to follow when we want to convert epsilon NFA into NFA. We have to eliminate all the epsilon transitions. So if there is an epsilon move from state P to state Q, then it can be removed as follow. The first rule is all moves from Q should also originate from P. So whatever moves we have from Q, those we have to replicate from Q, and if Q is a final state, then make P as a final state. Let us try to understand with the example. Assume that this is our transition with epsilon move and we have to eliminate it. So what rule says that if we have epsilon move from P to Q, then we have to replicate all the transitions of Q from P. So we have one transition on Q that is originating from Q and remaining on Q. So we have to create one transition from P which goes to Q, something like this, because the transition of Q is pointing to Q itself. So transition from P should also point to Q and the input alphabet is B. The second rule says that if Q is a final state, then make P as a final state. So in this particular NFA, Q is final, so we have to make P as well as final. So this is the equivalent NFA without epsilon move for the given epsilon NFA. Let us consider another example. Here we have two transitions on state Q. They are originating from Q and they are remaining on Q. So first, as a first step, we have to replicate all the moves of Q and they should originate from P. So it looks like this, where we have to originate two transitions from P for input alphabet A comma B, and it should point to the Q because the transitions from Q are pointing to Q itself. And finally, Q is a final state, so we have to make P also final. So this is how we can convert any epsilon NFA into NFA. But for small NFA, it is simple. If NFA is larger, then this process might be a bit trickier. So we have to go state by state. Consider epsilon NFA for the given language and we have to convert it into NFA. So language says that our NFA should read n number of A's followed by m number of B's followed by some p number of C. So this is the equivalent epsilon NFA. Now we will move one by one step. First we'll try to reduce the epsilon transition between Q1 to Q2 because Q2 is a final state. So we may need to back propagate it in the reverse order. So first we'll eliminate epsilon transition from Q1 to Q2. So there is a one arc from Q2 that is originating from Q2. So we have to create one arc from Q1 for alphabet input C. And the arc which is generated from Q2, it is also terminating in Q2. So whatever arc we are adding from Q1 should point to Q2 and the input alphabet should be C. So this is how we can eliminate that epsilon transition. And Q2 is final state, so we have to make Q1 also final. Next, we have to remove the epsilon transition between Q0 to Q1. And as we can see that there are two transitions from Q1. On input B, it remains on same state, and on input C, it goes to the Q2. So we have to add two transitions on state Q0. On reading B, it should go to Q1. On reading C, it should go to Q2. Fine. And Q1 is a final state, so we have to make Q0 as well also final state. So when we eliminate epsilon transition from Q0 to Q1, it looks like this. The conversion shown on previous two slides was manual. So when we have big epsilon NFA, it would be hard because there would be many epsilon transitions and many states. So probably we might miss some of the arc or some of the states. So more mathematically or in more formal way, we can convert any epsilon NFA into NFA using this algorithm. The step one, we have to find out epsilon closure of all the states that we have already learned in previous video. Now for each state Qi belongs to capital Q. So capital Q is set of all the states in given epsilon NFA, and Qi is the one state from that. So we are picking one by one state and we are doing some processing. What we have to do is for each input alphabet symbol, AK belongs to sigma. So sigma is set of all the input alphabets, maybe A, comma, B, comma, C, etc. So one by one, we have to pick up all the alphabets from that symbol. What we need to do is we have to compute delta dash transition function. So far we have discussed only delta transition function and extended delta transition function. Now to convert epsilon NFA to NFA, we need to find out delta transition function, and which is defined in this way, the delta dash of Qi. So Qi is the state coming from capital Q, comma AK. So AK is the input alphabet which is coming from sigma. So for each pair of Qi, comma AK, we have to compute epsilon closure of delta of epsilon closure of state Qi on input alphabet AK. This process we have to repeat for every pair of Qi, comma AK. And once it is done, we have to construct NFA without epsilon from the result obtained in above steps. Let us try to understand this with the help of example. So this is the given epsilon NFA and we need to convert it into NFA. So as a first step, we have to find out the epsilon closure of all the states. So this is just a transition table for above diagram. Epsilon closure of Q0 is Q0, Q1 and Q2, because just by consuming or reading epsilon, we can go to Q1 and Q2, and state itself is by default epsilon closure of itself, right? So epsilon closure of Q0 would be Q0, Q1, Q2. That is for Q1 will be Q1 and Q2, and from Q2 there is no any other arc on epsilon, so Q2 will be the epsilon closure of Q2. Now for Q1 we have three alphabets A, B and C, and we have three states Q0, Q1, Q2. So we have to find out delta dash transition function for Q0A, Q0B, Q0C. Same we have to do for Q1A, Q1B, Q1C, and Q2A, Q2B, Q2C. And this is how we can compute it, that for any state Qi and for any input alphabet AK, we have to compute epsilon closure of delta transition of epsilon closure of state Qi and input alphabet AK. So we will start with Q0 and input alphabet A. So that is given by epsilon closure of delta, epsilon closure. Now Qi is replaced by Q0 and AK is replaced by A, because first line is the general form of rule and the second one is the specific one. So now we will compute we have already computed epsilon closure of Q0. So that epsilon closure Q0 will be replaced by the set of states, that is Q0, Q1, Q2 and A. So we have to compute the delta transition from state Q0, Q1, Q2 on A. So ultimately it's nothing but it's a union of delta Q0A, delta Q1A, delta Q2A. So we have to find out the union of transitions from Q0, Q1 and Q2 on input alphabet A. So that is nothing but it's just a Q0, as we can verify from the transition diagram. And again we have to find out epsilon closure of that. That is nothing but Q0, Q1, Q2 as we already computed. So this procedure we have done for input alphabet A for state Q0. Now we have to repeat it for input alphabet B. So that would be epsilon closure of delta, epsilon closure of Q0 on B, and that would be delta Q0, Q1, Q2 and B. And on input alphabet B, you can see it remains on state Q1 only. From transition diagram, we can verify that if we take the union of all these three states, then that gives us Q1 only. And epsilon closure of Q1 is Q1, Q2. And finally, we will repeat it for C. And same, when we read it C, it remains on state Q2. And hence, the delta dash transition function for Q0C would lead us to Q2. So this is for Q0. Same process we have to repeat for state Q1 as well. So this is our partial transition table now. So you see that now we got some different transition table compared to the original one. And this is our partial NFA. Let us now compute it for state Q1. So delta dash Q1A would be epsilon transition of delta of epsilon closure Q1A. So closure of Q1 is already computed, that is Q1 comma Q2 on A. And if we look at the transition table, then delta Q1A is phi and delta Q2A is also phi. Fine. There is no transition for input alphabet A from state Q1 and Q2. So this is phi. and epsilon closure of phi is always phi. Next, epsilon closure of B, that would be epsilon closure of Q1 would be Q1, Q2, and on input alphabet B, we have one transition from state Q1, that is Q1 itself, and that will give us the output Q1, Q2. And similarly for delta dash Q1 comma C, this is how we can compute the closure. And if we put the appropriate value, epsilon closure of Q1 is Q1, Q2. And from Q2, we have one transition on input alphabet C, that is Q2. And hence the output would be Q2. So necessary arcs we need to add it to the partially constructed NFA. There is no transition for alphabet A. There is a one transition from alphabet 2, that is on Q1 and Q2. So that will be like this. And for input C, there is a transition on Q2, that is already mentioned. Next, we have to repeat the process for state Q2. So in same line, we will repeat the process. So for A, there is no transition. For B, we have no transition. And for C, there is only one transition, Q2 is possible. So when we add it to the transition table, it looks like this, and arc would look like this. So this is the final NFA. As you can see, there is no epsilon transition present, and for same input, there are multiple outgoing arcs. So this is NFA. Thank you. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.